Welcome back to Math for Technology. In this video we're going to finish up Chapter 8 and we're going to talk about Law of Cosines. In the last video we started working with oblique or non-right triangles and we used the Law of Sines to do that. We were able to do that because we had a pair where we knew an angle and its opposite side. In this section we need to use the Law of Cosines because we no longer have that pair. Our two scenarios are that we have two sides and the angle included, or we have all three sides. So we have the law of cosines here, and so you can see that there's a pattern. We have whatever letters on the outside, we have the opposite two on the inside. The angle at the end matches the side that's on the outside. We would use this first set of information, or this first set of formulas, if we're looking for a side length. This is an alternate method or alternate formula that has been produced. It's just found by moving and manipulating the upper ones. If you're looking for an angle, you will use this section. Once you do the stuff on the right hand side, you will do the inverse cosine in order to find the angle. A third formula that's found in this section is how to find the area of a triangle, and that is found by doing 1/2 AB sine theta. So now that we have all the formulas, we're going to go ahead and start doing some practice. So the first one says solve a triangle with the known values of A equals 9.3, B equals 16.3, and C is 42.3. So the only information that you have to know besides that is it is definitely a non-right triangle. So I'm going to go ahead and draw a triangle to start with. I kind of tend to do these just very generic so they don't necessarily show the information that is given. This is side A and it is 9.3. This would be side B and it is 16.3. And I have angle C of 42.3 degrees. So you can see we can't use the law of sines because I don't have both C's, both A's, or both B's. I'm going to find side C first because it is opposite of the given angle. So I'm going to use the one that is C squared equals A squared plus B squared minus 2AB times the cosine of C. So little a is 9.3 squared plus 16.3 squared minus 2 times 9.3 times 16.3 times cosine of 42.3. I would go ahead and just plug all of that in my calculator in one fell swoop. So I'm typing in 9.3 squared plus 16.3 squared minus 2 times 9.3 times 16.3 times cosine of 42.3. Do make sure your calculator's in degrees. I end up with that C squared is 127.938 with some other numbers. So of course, since I'm looking for C, I will need to square root that. So C is approximately, and since B and A are to the 10th place, I'm going to go ahead and go to the 10th place. So I get 11.3. Now with this information I have choices. I can either now, because I know both C's, I can switch back to doing law of sines, or I could use one of the angle formulas to find angle A or angle B. Either way you're going to have to use this 11.3 approximation. I'm going to go ahead and just practice and show you how to do it with the law of cosines. I'm going to find, since I have both A and B to still find, I'm actually going to find the largest angle first, and the larger of A and B would be angle B because it's across from the larger side. So I'm going to go ahead and find angle B first. So to set it up, we're going to do cosine of B equals, let's just verify real quick up here. So if I'm doing cosine of B, we're going to do A squared plus C squared minus B squared, so the one that we're minusing matches the angle that we have here. and then the A and the C on the bottom match the first two. So we're going to do A squared, which is 9.3 squared, plus C squared, which is 11.3 squared, minus B squared, which is 16.3, divided by 2 times 9.3 times 11.3. So I'm going to go ahead and do everything on the right. 9.3 squared plus 11.3 squared minus 16.3 squared. Then I'm going to divide that by 2 times 9.3 times 11.3, and I get that it is negative 0.243 with a bunch of other numbers. So the last thing I'm going to do is do the inverse cosine of that number, and I get that angle B is 104, and since my degree is to the nearest tenth, I'm going to stay consistent, so 104.1 degrees. Now to find angle A, still triangles add up to 180, so all I have to do is do 180 minus 42.3 minus 104.1, and I get 33.6. And so I've solved it. I know everything about the angles and the sides. When you're doing these problems, take a moment. B is my largest angle, and side B is my largest side. Angle A is my smallest angle, and side A is my smallest side, so it does make sense. So let's go down and look at example 2. This time, instead of given one angle, I'm given no angles. I simply have 3 sides. I don't start it any different. I just draw a generic triangle, and I just label it A, B, and C. We're going to put on what I know. I know side A is 19.52, side B is 63.42, and side C is 56.53. This time I'm looking for all the angles, and to stay away from what's called the ambiguous situation, which is there's more than one option, always try and find the largest angle first. So I'm looking for largest side. Side B is the largest side, which means angle B would be the largest angle. So I'm going to do angle B first. Well, that is what we did in the last one. So we're going to follow the same formula. So cosine of B is A squared plus C squared minus B squared, because we minus the one that matches the angle we're looking for, divided by 2 times the ones that don't match. So we'll go ahead and plug all that in. 53 squared minus 63.42 squared. Divide that by 2 times 19.52 times 56.53. I got negative 0.201, several other numbers. I'm going to inverse cosine that so I can find its angle. And this one is 101.6 degrees. Now that I know angle B, I'm going to go for the next largest one. So the next largest one would be angle C. So I'm going to do cosine of C. Since I'm looking for C, I'm going to subtract C. That'll be the one on the end. So I'm going to start with A, and then I'm going to move to B. This time I'm subtracting C, and and I'm dividing by 2 times A times B. So it's very similar. We really just moved one number. I realized I didn't put the square on the 56.53. Times 19.52 times 63.42, and so this time I have a positive 0.487 with a bunch of numbers. Inverse cosine gives me an angle C of 60.8 degrees. Now to find angle A, 180 minus 101.6 minus 60.8. And so I end up with 17.6. And I should be good to go because of the order I did it in. Largest angle, largest side, smallest angle, smallest side, and then in the middle. So I used law of cosines the entire time. You could have, once you found the first one, switched back to law of sines if you prefer. So this last one we're going to do is to find the area of a triangle with known values of side A, side B, and angle C. That formula only works if you know the two sides, if you have two sides and the included angle. And the formula above, as we look at it, has side C here, or sorry, angle C. It doesn't matter, these can be moved around. This could be angle A, then you would want B and C sides. If it was angle B, then you would want sides A and C. So we're going to find that area of our triangle. It's going to be 1/2 times 9.72 times 3.84 times the sine of 117.5. The nice thing is we just get to plug that in, letting our calculator do all the hard work for us. And so we end up with an area that is approximately 16.6 centimeters squared. It's definitely easier than trying to find the height, which we could have done. If we would have drawn it out, we could have split it, found the height. We could have tried to do Heron's formula, but it's so nice when we have formulas like this. So if you have any questions on this section, please let me know. With that, we're finishing up Chapter 8. Once you get this assignment done, go ahead and start working on the review and preparing for the test. Have a good day.